To re-record my video. Hi class! We are starting 3.4 factoring trinomials and finding x and y intercepts. So we have learned how to factor when we have 4 terms, but this is us learning how to factor when we only have 3 terms. So notice we have a 2x squared, a 7x, and a negative 15. Our first step is to multiply a and b. So let's just go ahead. A is 2, b is negative 7, and c is 15. Multiply a times c, so that's 2 times negative 15, but add to a b of negative 7. So I'm thinking what multiplies to 30? I think I can make 3 and 10 work. If I make the 10 negative and the 3 positive, I can multiply to negative 30, but add to negative 7. So I'm saying that negative 7x, that this is the same as negative 10x plus 3x. So I'm just rewriting that middle term. All the work I did in the maroon there was just to break up the negative 7x squared. So I'm saying that my negative 7x is the same as negative 10x plus 3x. We should all agree with that. Now that I have it as 4 terms, I can do my difference of squares. Or, sorry, not difference of squares, factor by grouping. I needed to do my ACB tree in order to find the perfect way to rewrite that negative 7x. So I should be able to get my matching and my leftover. I can pull out a 2x, can pull out a positive 3. I get my matching and my leftovers, and we're rocking and rolling once we have 3 terms, or 4 terms, because that's what we're used to doing. So here's my leftover, my matching. We're going to go ahead and do this again with example 2. In the maroon, I know that I want to see if I can rewrite this negative 5x as 2 different terms. So a times c, let's identify my a, b, and c again. A times c is 6 times positive 1, so what multiplies to 6? But adds to a b of negative 5. So 6 is 1 and 6, 2 and 3. I can make my 2 and 3 both negative. So I'm saying that 5x is the same as, or negative 5x is the same as negative 3x minus 1x. Oh, sorry. I forgot to switch my colors back. Forgive me. So now I'm back to 4 terms. I have my matching. And my leftovers. So here's my leftovers, here's my matching. So that's how to factor trinomials. We're now going to tie our factors into this idea of y-intercepts. So y-intercept is a point that intersects the x-axis, or an x-intercept is a point that intersects the x-axis. So just remember the x-intercept is this is the x-axis, the horizontal line. Parabola can have 2, 1, or 0 x-intercepts. If it has 2, it's going to cross the x-axis twice. If it has 1, it's going to cross the x-axis once. If it has none, it's not going to cross the x-axis. So how our factors tie into this is the idea of a zero product property. So that means any number times a 0, that if 2 numbers multiplied equal 0, one of them for sure has to equal to 0. So if you want to think of it, if a times b equals 0, then a and or b is equal to 0. This ties into factors because I know that 3x has to equal 0 or x plus 2 has to equal 0. And this ties into my x-intercepts because I am saying that my output is 0. So we're saying that my y is 0. So this is like saying 3x, x plus 2 equals 0. I know my y is equal to 0. So if I find my x-intercepts, I'm saying my y is equal to 0, and each of my factors can be set equal to 0. So this example A would have y-intercepts at x equals 0 and x equals negative 2. My example B, I'm going to set each factor equal to 0, and this is where I would have y-intercepts. So x equals 4, and once you get to this point, it's just like solving one or two step algebraic equations like you did in Algebra 1. So these x-intercepts are also known as the roots or the zeros. So we are essentially finding the x values that cause the output to equal 0. Okay, you're flipping to the back page. So how to find the x-intercepts? We want to write it in standard form. Step 1, we want to make y equals 0. And then we want to factor, set each factor equal to 0. So this is two terms. I'm going to pull out a 3x because that's my greatest common factor. That's x minus 2. I can't factor that any further, so I'm going to set each factor equal to 0. So 3x equals 0, x minus 2 equals 0. So x equals 0 and 2. My example B, I'm going to make y equals 0. And I'm going to factor. I have to do a little bit more work to factor here. I'm going to do this in maroon again just to be consistent. Here's my A. My B is a 1. My C is negative 6. A times C is negative 12. So it multiplies to negative 12, but adds to my B of 1. I'm going to try 4 and negative 3. So I'm saying that 1x is the same as 4x minus 3x. I'm going to write this a little better. Then I can go, now that I have 4 terms, I can do my factor by my 4 terms, so I can do factor by grouping.
Yeah. We're the worst. We never help them. Yeah, of course. And we actually just make sentences. Yes, that's yes.
So now I have factored this, and I can set each factor equal to 0.
100%. 100%.
So here, I would have a y-intercept at x equals 2/3 and x equals negative 2. The last one you do is a trinomial again. So I'm going to do my ACB tree, and I'm going to work to rewrite my 4x. My a times c is 4, multiplies to b of 4. So I'm going to use 2 and 2, plus 2x plus 2x. We'll pull out an x. We'll pull out a 2. Matching and leftover. These are the same terms, so I need to set 1 equal to 0. But when x equals negative 2, that would be my y-intercept, or x-intercept. Okay, this is the last little bit we need to do. We need to practice graphing these. So we know how to graph these. This is in standard form, so we could find a vertex by doing negative b over 2a, etc., etc. Or we could go by finding our zeros. So we're going to go ahead and find our zeros. So I'm going to set 0 equal to x squared minus 2x minus 8. I'm going to do some work to rewrite. A times C is negative 8. But adds to my B of negative 2, negative 2, and positive 2. So I'm rewriting my negative 2x is negative 4x plus 2x. So here's my matching. Here's my leftover. I can set each of these terms equal to 0. And this is where I cross the x-axis at 2 and 4, or negative 2 and positive 4. I also know my y-intercept is 0, 8 because of my, or 0, negative 8 because of my C value. So I can kind of anticipate my graph looks something like this. It makes sense my A is positive, that's opening up. So I have a situation with the rocket. This is the last problem. You guys are doing great. This is a situation with the rocket where the height is there. It wants to know when the rocket will hit the ground. So when a rocket hits the ground, its height is 0. So if we think of this graphically, it's like going up and coming back down. It also makes sense that's what it looks like graphically because we have a negative parabola. So I'm going to set my height equal to 0. And once my height is equal to 0, I'm trying to find out what time makes this 0. So here's my A, B, and C. A times C. Or actually, let's take a step backwards. I can factor out a 16.
Oh, yeah, right.
So now I'm going to try this with this A, B, and C. My A, B, and C just got a lot smaller. A times C is negative 8. My B is negative 2, negative 4, and positive 2. And I can have my matching and my leftover. I can set each of those terms equal to 0. So it crosses the ground at 4 and negative 2. It does not make sense for our negative 2 to be used because there's no negative time. So that means our answer would have to be at 4 seconds. So at 4 seconds, the rock will hit the ground. The rocket